the seminar on designing interconnects with complete technology. This is an overview of what I'm going to be talking about, and I'm going to briefly cover what complete technology actually means, and that involves solvers and tools. I will focus a little bit on the thermal solver, and then I'll go on to some examples, namely a backplane connector and a USB cable. And then I'm going to finish with a quick look at some mechanical issues. So CST has complete technology. So this is something that we've kind of marketed ourselves with having for a number of years. And with many marketing terms, you can't be too specific because being specific is not that catchy. So you may wonder, okay, that sounds good, but what exactly is it? And it actually makes a lot of sense, especially when you're considering numerical techniques and electromagnetics. CST's complete technology is all of its solvers and tools. And what I mean by that is there's no solver that fits every single application. That would be nice, but we don't have it. And there's also the case that whatever your application is, it may be that several solvers can be used to simulate it, but one is probably going to be better than the others. Sometimes there are challenges with simulation. So in those cases, you could use tools to help develop elegant workflows. We don't have enough time today to cover all the tools that CST has, but we will take a look at a couple, and hopefully you'll get the idea. And it's very timely to talk about complete technology right now because CST's standard license now has all of the solvers included as standard. And when I did a very brief kind of count up of how many solvers we have at least 24 solvers, probably more, and 8 distinct numerical methods, and again, probably more. And we're going to take a quick look at some of those that will be of use within the interconnect and connector application area. Okay, so for electromagnetics, you have all of these different applications that use electromagnetic physics. Those come in a variety of flavors, or we can break them down a bit more, and these are the ways that they're broken down for simulation purposes. You can have very wide band, narrow band, large electrical size or small electrical size, and then you have certain applications which have resonance. So we take the transient solvers, and CST has 2 best-in-class transient solvers, so that can be very useful for medium to wide band, medium to large electrical size. We take the frequency domain solver that can be used for medium to small electrical size and also highly resonant structures. It's often beneficial. Integration equation, MOM method, can be used for larger applications, and for very large applications you can use the asymptotic solver.